Now we're going to do activity 152. So this is dealing with a mixing problem. So in this case, we've got a 1,000-gallon tank. It's got 200 pounds of salt dissolved in the water. You've got pure water coming in at 6 gallons a minute and mixed water going out at 6 gallons a minute. So whenever you're doing a mixing problem, first, what should be the name of our variable? I propose our variable is capital S for salt. So then, what is the change in salt in the tank in regards to time? Change in salt, so ds dt, in these mixing problems, it's always equal to rate in minus rate out. Okay, so the rate in is 0 because there's no salt in pure water. And then the rate out is going to be, it's 6 gallons a minute. So let's say T is in units of minutes. That makes things nice. And so how much salt is leaving? Well, whatever mixture of salt, so the density of salt in whatever pounds per gallon times 6 gallons. So what's the density of the salt? The density of the salt is however much salt you have divided by the volume of the tank. In this case, it's holding steady at 1,000 because the amount in and the amount out are the same. And then make sure you realize that it's an S. All right, so S over 1,000 and then times 6 gallons a minute. And so, well, 6 divided by 1,000, there's a great way to represent that is just the decimal notation, 0.006. And so I can move that to the other side as well. So ds over dt plus 0.006 s equals 0. Well, I mean, this problem is kind of boring for this section. This is separable. So let's separate it. I shouldn't have done that. I should have just separated it. So ds over dt equals negative 0.006 times s. So then separating it, you have ds over s equals negative 0.006 t. Well, that means that the natural log, that was the value of s, equals the integral of, no, there's no t there, it's dt. Integral of negative 0.006 dt. So natural log of absolute value of s equals the equals negative 0.006 t plus c. And then since s is always going to be positive because it's an amount, you can drop the absolute value. But even if you didn't know it was an amount, you can still do e to the power of both sides. So then you got absolute value of s equals, and e to the power of this, it's like the thing we've done several times. So I move the new constant, even though it's still called c, it's a new constant, times e to the negative 0.006 t. And then we've got initial conditions to consider. So our initial conditions was that at time equals 0, I had 200 pounds of salt. Oh wait, and yeah, I'm dropping the absolute value because the constant can follow up. S equals, and then at time equals 0, I've got 200 pounds of salt. So if I plug in 0 here, I get 1. So it works out nicely to have 200 times e to the negative 0.006 t. So that is That's our initial value problem that we solved. How long will it take until there's only 20 pounds of salt left in the tank? So then 20 equals 200 e to the negative 0.006 t. So then 20 is 1/10. So e to the negative 0.006 t equals 1/10. Well, negative 0.006 t equals natural log of 1/10. And then t equals natural log of 1/10 divided by negative 0.006. So if we pull out our handy dandy calculator and do, let's see, kicking it old school here. So 1/10 is 0.1. And then I want to do, I can't remember if this is log base 10 or log base e. Let's go there it is. Natural log of that divided by 0.006 negative equals 383. So t equals 383.76. Now, remember what units our t is in. It's in minutes. And so I don't know if you want to convert those decimals to seconds or not. You could if you wanted to. It'd be more useful if you're actually using this. No one says like 0.7 minutes. So let's do that. So 383. So then get down the decimal point. So subtract 383. And then multiply that by 60. And that's in 45.85 seconds. So, and 45.85 seconds. And that's way more precise than you probably need in this sort of situation, because, I mean, what does it matter if you're trying to get down to 20 pounds, and what does it matter if you're off by 1/100 of an ounce, you know? So that's activity 152.